Good afternoon, good evening to you, wherever you're at out there in the world. Welcome to the Cloud Flight Simulator Part 1 webcast. I hope you're slowly easing your way into the new year like I am. So this is the first official thing I get to do here in 2024, and I'm super excited to bring this to the SANS community. The content of this webcast has been a lot of work, especially from some of the authors for Sec 540 and a lot of the contributors and instructors for that course. So I'll give everybody their due shout outs as we push forward here. The title for today's content is GitLab CI, Workflows and Secrets. It's a lot of introduction to kind of CI/CD and what that looks like in GitLab, as well as how we can use some of the more modern OpenID Connect integrations that are available in GitLab CI to communicate with some external cloud systems. In this case, we'll take a look at how that works with HashiCorp Vault. Before we jump in, real quick introduction. My name's Eric Johnson. I've been a part of the SANS cloud security curriculum since the beginning. With Sec 540 was one of the first courses that we were involved in for DevSecOps and cloud security automation. And most of the content today is very directly related to what we're covering in that class. Also Sec 510, which is more cloud security, the ability to kind of use attack-driven defense to build out different misconfiguration prevention policies and how to go through and audit some of your cloud accounts and things like that. And also Sec 549, which is all about enterprise cloud security architecture. When I'm not teaching or authoring content for SANS, I'm a principal security engineer at Puma Security, where I focus on cloud infrastructure assessments and automation and security reviews and architecture and doing lots of security tools automation. So all sorts of fun things that pretty directly relate to the topics that we'll talk about today. You can find me on LinkedIn at eric-m.johnson. Hopefully I'll be able to connect with some of you out there after the session is over. If you've got questions or want to dig into the topics any further, please feel free to reach out and let me know. This is the first part of a four-part series that we called the Cloud Flight Simulator. Part 1 is today, obviously January 4th. Make sure you jump in and sign up for part 2, 3, and 4, which are happening roughly every 2 weeks on Thursdays for the next month or so. So on January 18th, Ben Allen is going to give us a discussion on protecting Kubernetes clusters with admission controllers, which is a really important security policy guardrail that we can use in cloud native systems in order to prevent container images from launching or enforce base image policies and say they have to come from trusted registries and things like that. So Ben will be covering that on January 18th. Part 3, Jon Zeolla is going to give us a nice walkthrough for safeguarding the software supply chain. Jon will go through some of the software levels for supply chain assurance, or SALSA, and take a look at what SBOMs are and how those can be automatically generated using some tools, and how to go in and sign some images, and maybe also give attestations for where our builds are taking place at. So jump in on February 1st to go through that with Jon. And then I'll wrap up part 4 on February 15th. And that's going to go through using some of the cloud native integrations with Kubernetes to assign workload identities to pods. And it'll also kind of be directly related to some of the OpenID Connect content that we'll look at today, where we can use the Kubernetes OpenID Connect built-in identity provider to assume a role in AWS or log into an Azure tenant using a service principal. So those are the different topics that we'll cover throughout the series. Today's content, we're going to focus on the intro to setting up some of these pipelines that can deploy some of these things. So in order to know how to do that, we'll take a look at some of the CI/CD tooling that's out there, some of the trends in the space that we've seen in past cloud security surveys here at SANS, and eventually we'll land on GitLab. GitLab CI has been around for several years, and we've been watching it very closely to see how it has matured over time, specifically in the community edition of GitLab, which is what we use in some of our SANS courses. That's an open source version of GitLab, and it is freely available, and you can download that and you can run it internally, or you can host it on a DevOps server, which I'll show you the environment that I've got that running on here in a little bit. And then I'll show you the OpenID Connect option inside of it. And we'll take a look at how that OIDC integration works inside of a running pipeline. I'll deconstruct the JWT for you so you can see the token and the claims in it. And that will set us up for part 3, which is how we can use that token to exchange it with HashiCorp Vault to authenticate into the vault using that temporary token rather than a long-lived vault token that might live for weeks or months or however long you've got it set up for. So that's the roadmap here for the discussion. This will be fairly demo heavy as well. I'm going to talk about a few topics, and then we'll take a look at a live running environment that I've got set up, and we'll see some of these things in action to help kind of validate some of the points that we've made in the slides. So let's go ahead and jump in with the opening discussion here. As far as CI/CD goes, what does the tool chain actually look like? And over the years, one thing I've always said is that if you understand how one of these works, you pretty much understand how all of them work. They are all just shiny wrappers around a bunch of Bash and PowerShell scripts. And all you're really doing is setting up a workflow, step 1, step 2, step 3. And if step 1 succeeds, it'll turn green. If step 2 succeeds, it'll turn green. If step 3 fails, that workflow will stop and you'll have some output and it will say, hey, Eric, this step failed and we can't move forward. You need to go fix that bug or that failing test or that bad line of code, whatever it is. And then you can run the pipeline again and get that quick, fast feedback to make sure that it's functional. So that's the goal of these tools. And we saw this initially jump in and be very heavily adopted decades ago by the development teams. And development teams were using these to build their binaries, read code from source control, build a binary, deploy it to a server. Over the years, we've seen this also be extended into a lot of other disciplines. Cloud infrastructure as code is a thing. Deploying objects out to Kubernetes clusters. You can use these for security analysis. We have lots of vulnerability data pipelines now that are running inside of these things to pull data from lots of different scanners, aggregate, deduplicate, analyze, and then open up Jira tickets or potentially fire off alerts if evil things are happening. The sky's kind of the limit with this. You can really take any process and just start to automate it using any of the tools that I'm showing you on the slides here. Now, the very first one that kind of exploded into the world was Jenkins many, many, many years ago. And Jenkins is an amazing tool. It still is. For various reasons, though, as you take a look at some of the other options on here, you've got the cloud-specific ones with Azure DevOps and Code Pipeline. And then what I'll call the leading two at this point because of the ease at which they integrate with the version control systems or GitHub Actions and GitLab CI. They all have some differences and some nuances. And over the years, we've been surveying which options are people actually selecting here. And in 2021, you can see that, Jenkins is kind of leading the way there. In 2022, Jenkins is still, by 60% roughly edging out a lot of the other options. But as you talk to people and you ask them, okay, what's the current state here on a lot of calls that I do or working with customers, et cetera, well, everybody, it seems like at this point, has a plan. If they're not already in GitHub or GitLab, there's a migration effort underway to get there. And when they get there, what they realize is that, well, there's a lot less responsibility in the ease at which we're integrating a lot of these CI/CD workflows can be done very simply and very quickly just by using GitHub Actions or GitLab CI, which are their integrated ways to do this. So I think the responsibility model, you can see that following what a lot of folks are doing by moving to the public cloud with AWS, Azure, and Google, is to let's eliminate a moving part from the workflow. Rather than having GitLab kick off a Jenkins pipeline, I can do it all in one place. And I can have one consistent location to look for my build results and my error logs and things like that. And I also don't need to go maintain some other system and configure it and harden it like we've done for many, many, many years. So those are some of the reasons why I think This is trending more towards your cloud-hosted CI/CD solutions, which would be your GitLab and your GitHub options. I know personally, we had a lot of Jenkins pipelines for many years, and we went through the same migration, probably maybe a little bit more of an early adopter than a lot of enterprises out there. And I'm not saying that Jenkins is going to go away by any means, but one talk that I listened to a couple of years ago from John Stephen at one of our CloudSec Next summits, John said Jenkins had its day for the last decade, and the version control systems, i.e. GitHub and GitLab, are going to own the next decade. And the trends that we're seeing support that. As you take a look at maintaining a on-prem kind of CI/CD service, and it's not just Jenkins, it could be running like TeamCD on-prem or Circle CI on-prem. There's operational support involved there. Somebody on the sysadmin side is going to have to spin up servers. They're going to have to harden those networks. They're going to have to patch those servers, and they're going to have to manage upgrades to those particular CI/CD tools that are running on it. There's also a massive plugin ecosystem for Jenkins, thousands and thousands of plugins, which is amazing because the tool is very, very extensible. The downside is that not once have I ever gone to the management dashboard in Jenkins and not been met with this massive red warning banner that says, hey, Eric, you've got 38 plugins with vulnerabilities in them, and you need to go in and patch all those things. So it's just constant plugin patching to keep up with the security flaws. If you take a look at all of the effort and all of the overhead doing that work, and then you look at GitLab CI, for example, and you say, oh, all I need to do is just write this little file and put it in the repo, and GitLab's going to pick it up and run it on their own builders. So the integration into version control is huge. The runners are high availability. They auto scale. All that's part of the cloud provider's responsibility model. Now, that doesn't mean they don't have problems. I have seen outages from GitHub and GitHub Actions where it says, hey, we're experiencing performance problems. Bear with us. We'll get it sorted out. But once I read that, I can kind of move on with my day and say, okay, my pipelines are running again. Cool. They figured it out, versus me being the one that's got to go onto the server and figure out what's happening and reboot things and go fix the network congestion problem that's happening or whatever. So it just follows that whole responsibility thought with the cloud providers. We're letting Microsoft or GitLab, for example, manage those particular issues for us, and we can focus on delivering features, doing whatever it is that we're trying to accomplish inside of this system. The cloud-hosted CI services also are able to be integrated with on-prem servers as well. If you really need a workload or some build to happen on-prem, you can set up self-hosted runners, and those runners will just run an agent on it where it'll go pull the repo inside of GitLab or GitHub to say, has there been an event that I'm responsible for building that has occurred in the last 30 seconds? And if it picks up on that, it'll run that job on your own servers on-prem. So you can still keep some of that on-prem functionality if you really want to. You're just not really responsible for parsing the workflows and going through and making sure that the event triggers are working and setting up, kind of the central primary server for the CI/CD solution. It's just the runner that you're responsible for. So those are some benefits by moving over to a cloud-hosted CI/CD service. How are they similar? They're all just using configuration as code. It's a file or a workflow that you put in the root of the version control system. In the Jenkins world, it was called a Jenkins file, and that was written with a Java-like syntax called Groovy. And as you move over to GitHub and GitLab, it's all in YAML. And that largely, I think, over the years, we've become pretty comfortable with writing YAML, as it's taking over the world with tools like CloudFormation or tools like all the Kubernetes manifests are going to be written in YAML. A lot of the security tools, configuration files are also in YAML. So we're getting comfortable with that syntax. And if you've been writing lots of YAML, like with Ansible or something like that, you're going to have a pretty easy go at writing some of the CI/CD workflows inside of GitHub or GitLab. It's the same structure, just different schemas that you've got to follow. At the end of the day, though, all they really do is execute a bunch of Bash and PowerShell scripts. And I'll show you some examples of that as we jump into the demo here in a little bit. But it's really just, I want you to run this script first, check the output result. I'll run this script next, check the return code. Okay, that's cool. And then we'll just move on through our workflow. And that could be done by any of these tools. So I'm proud to announce, those of you that have taken Sec 540 with me or any of the other awesome instructors in the past, Jenkins has been our go-to CI/CD service for many, many, many years. But following the trends over in the surveys and feedback from students, I've got a screenshot on here that if you go to a special URL in our new virtual machine environment, we show our friend Jenkins holding a cup of coffee saying that, hey, Jenkins has been retired from service in the class. And we thank Jenkins for his many years of service. We'll just say that Jenkins can go on and enjoy his coffee on the front porch every morning and not worry about doing all the builds and all the work for us. So with Jenkins kind of moving into the retirement phase, GitLab CI is our chosen workflow. On the YAML side of things, the file that you're really looking for is gitlab-ci.yaml. That's where that file is going to live at. So what we want to do there is go in and set up an event trigger. What's going to make me run, and that could be a commit to the main branch. It could be a commit to a feature branch. It could be if I create a tag on the version control system, something to say, start the job. So that's the first thing you'll have to define. And then you can go through and create a bunch of essentially stages. And those stages can be made up of one to many jobs. And each job is going to define, where am I running the scripts at? What runner is this actually going to happen on? And that can happen on the host runner via shell exec. It could also happen inside of a Docker container if you've got a bunch of builder images, which we've got in our demo environment that I'll kind of show you. So it's pretty flexible. Once you set all of that up, you can then go in and start running your security tooling and your development tooling and your Terraform jobs and whatever it is that you're actually trying to accomplish. So before we jump into the more real world YAML file, let's walk through just a very basic example here. This is a GitLab CI YAML file. And what I've got here on the top of this, lines 1 through 6, is what we're looking at right now. Notice I've kind of created this base job format. And the base job itself is intended to be used or extended by other jobs. So we'll set up some of the baseline criteria. That way I don't have to copy and paste the same block into every single job under it. So if you take a look at the base job, notice on line 2, I've got an image there, and that's pointing to an actual container image that we're going to start the job inside of. So in this case, I have a local image called dm tools/builder-base:stable would be the tag value. And that image needs to exist in the local registry. And if it's not in the local, it'll try to go out and pull it from somewhere. So in this case, that would need to be in Docker Hub, for example, if I had an org called dm tools there. Now, the tags is interesting. That tells the job which runners to actually execute on. And you can have a lot of different runners in GitLab. I'll show you a couple. But all you need to know with lines 3 and 4 is that if I have a runner with a custom tag value on it called Docker, that's what's going to pick up and run this job. And then the rules tell you, when is this actually going to trigger? And in this case, what I'm saying is if the branch that a commit has happened on matches the default branch in the repo, which would be your main branch, commits to main, we're going to run the job. And you can go in and configure these base jobs to have all these characteristics and then use that in a job a little bit later. So we take a look at the second part, 8 and 9. You set up a bunch of global variables if you need them. In this case, my source code directory, where's the code at? And in this case, well, it's in the local directory /source/dm. That's where all the things are that we're going to process here. 11 through 14, there's some stages, and I might have different stages for initialize and build and deploy, where I'm going to run one-to-many jobs in each initialize stage before I move into the build stage and do some more work, before I move into the deploy stage and do some more work. So all of those different stages will be in the pipeline that I'll show you. And then check tools is going to actually use the base job that I created on lines 1 through 7. So if you look on line 18, I'm extending the base job and I'm putting it in the initialize stage. And then there's your scripts. As I mentioned, they're all just wrappers around a bunch of Bash and PowerShell scripts. In this example, I'm running JQ version. So I'm just kind of smoke testing the image, make sure that JQ is installed, make sure that kube control is installed. We're checking the version of the kube control client. And then if all that's good, I'm going to kick off an init.sh script. And I can even pass in that source directory variable that I declared up there on line 9. And GitLab will pick that up. And at the end of it, all it's going to really do is do a Docker run on dm tools / builder base stable. It's going to start that container up using that base image. And then it's going to run init.sh and it's going to go process some code that's inside of that script against that source directory. And you can take that concept and just run with it, start automating whatever workflow you are trying to automate in your CI/CD pipeline. So there's a number of different environment variables here. Also, I showed how you can pass a variable into a script, but in the env, there's also the build directory, the commit branch. There's also tags, a pipeline ID. There's a project directory where my code is going to exist inside of that image. You can use all of those in your YAML and your scripts to just figure out where things are in the current execution environment for a given job. So there's hundreds of those. Go through the documentation. Yeah, I think you'll find your way in there pretty quickly once you start working through these things quite a bit. And that will give you the ability to see kind of what data you've got available inside the job. As you start to do some real work, and now I just grabbed a job from a pipeline that I've got set up, and I'll kind of show you this here in a moment. But this is a more real world job where I'm going to start a scan using SymGrep, which is the lightweight static analysis tool that can go in and scan some code for me. And so I've got a builder underscore SymGrep image with SymGrep installed. And now I'm passing in some actual variables. So in this, I'm telling it, I want the results to be put into a certain directory, which would be in test/SymGrep. And that's defined on line 5. And then I'm kicking off a script, as you would expect, on line 9, where I'm saying run the SymGrep scan.sh script, and you pass in some variables so that script knows when I run the scan, where do I put the data files? Now, in this example, one thing that's unique to GitLab CI, specifically in the Community Edition, is that it is a little more limited as far as displaying test results than something like Jenkins is. I mentioned earlier, Jenkins has thousands of plugins, which is lovely for parsing different types of test data. So you could parse unit tests with Jenkins. You could also parse check style static analysis results. You can parse Serif results in Jenkins, and they'll all display on the dashboard when the build is done. In the Community Edition of GitLab, really just parsing unit tests, or JUnit specifically, is the de facto standard. So you're a little limited on what type of file you can pass into the reports option down there at the bottom. And you just have to make sure that the tool you're running supports a JUnit syntax in order for it to display correctly. And I'll show you what that looks like here in a moment. But at the short story here, we're taking the scan. So on line 7, we've got a results JUnit XML file is what we're requesting the file to be put into. So when I run SymGrep, it's going to take its output and put all of the findings into a test SymGrep / results JUnit XML file. And then in the artifact stage, what I'm telling the pipeline to do on lines 11 through 16 is store all the results in an archive so I can download them later. And then I want you to report on the test tab any of the findings that you find in that JUnit results file. So that's what that syntax will look like. And I'll kind of show you the front end view here in a moment as we jump into the first demo of the exercise, or the webcast, I mean. So one thing that we spent a lot of time on internally inside of SANS over the last 6 months or so is getting to a more hands-off virtual machine where you can just sign in and run with it. And Ben Allen, I have to get a huge shout out to Ben, who put a lot of effort into setting up what we're now calling the Cloud Flight Simulator. So you can show up to future SANS workshops or SANS cloud courses, and you don't have to download and run a VM inside of VMware. And it just is so much more simple. I'm so excited to get this out into the world. And I'll give you a feel for it here in a moment. But what we've got set up, at least in the 540 VM, is you can configure your browser proxy to use a SOX proxy to connect off to a DevOps server and install a CA certificate inside of Firefox. And boom, you can just browse directly to code.sans.labs or gitlab.sans.labs or workbook.sans.labs and access a bunch of these key services. So I'll jump over to that. And this is what it looks like. So this is just my Firefox instance. I'm on the OpenVS Code server that's running on here. And you can see that I've just cloned a bunch of different repositories there. It's got an embedded terminal, and I've got some commands and things that we'll walk through a little bit later, kind of pre-staged in the terminal. If we take a look at GitLab and we think about workflows here, one of the things that you've got to do to set this up is if we go to the admin area inside of GitLab, you want to go to CI/CD to find the runners. And we've pre-configured some runners on this particular instance of GitLab. And what you'll notice, I've got a DM DevOps 000, 001, 002, but they've got different tags on them. And I mentioned this earlier, when you set up your base jobs, you can choose whether you want to run a job, for example, the host, which if I open the host job up and I show some details here. So this particular runner is tagged with host, which means I'm going to run any of the scripts that are going to be run directly on the actual DevOps server. And the reason that that happens is because I've set this particular one up as a shell executor. And so now any commands are going to be run on the actual host if you need to, like Docker build or Docker push, things like that. On the other side of it, the Docker tag, there's a subtle difference here. You'll notice that the executor on this particular one is Docker, which means we're going to run all the commands inside of an image, a base image that I give it. So this is the setup that needs to be in place in order to actually define a different YAML configuration. And I'll just jump into one here. So if I jump over, this is a pipeline. This is a little app that I've got called the SANS Credit Union, which is a fictional kind of banking API. And you can see that I've got two base jobs here. So the host job is going to run if the tag is a host. So what that means to me now that I've shown you the runners is that's a shell exec. So that command is going to run on the host. And then the base job, that's going to run inside of Docker. So if we go through and you take a look at the various jobs, which there's a lot of different YAML in here, I'm going to just focus on that SimGrep one that I had looked at in the slide. So here's my SimGrep job. And the image is using the builder SimGrep image, which has it installed inside of it. And that also is extending the base, which is the Docker exec. So when this job runs, it's going to do a Docker run on this image. And then all of the script contents inside of here are going to run inside of that base image where SimGrep actually is installed at. So in this example, all we're doing is calling this build bin SimGrep scan.sh script, which is going to produce this results JUnit XML file. And then we're going to archive that and report on any of the results that were found in that JUnit file. So if I go back to take a look at the last build, and if you remember, that was the SANS Credit Union repository. When I make a commit to the main branch, and I've got a ton of builds queued up in here just from testing and playing around with stuff, I can open up this pipeline and we can actually view that. So here's the high level view, the visual view of what all that YAML actually does. So you can see, or if you remember, I've got a number of different stages for initialize, test, build, scan, package. Eventually we'll deploy it. So I'm doing a whole kind of supply chain container exercise in here. But the one that I just showed you was in the test stage. There's the SimGrep job. And you can open that up and kind of view the output. And here you can see us actually invoke the SimGrep scan. So there's the call to SimGrep scan.sh. We've got some output that goes to the console. And you can see that we've analyzed some files. There's, C#, Terraform, YAML, Docker files, et cetera in there. And then you can see that we uploaded the artifacts. And here's that results JUnit XML file. And it found an actual artifact with that name, and it will go parse it. Now you can browse to those artifacts, and we can say, oh, let's just take a look at the tests, the symgrep. You can always download the raw XML document if you need to, although that's not super pretty to look at from a user interface perspective. But if I go back to the high-level pipeline, this is why I want to parse those JUnit results, is we've got a test tab here. And anything that's formatted in that JUnit format is now going to show up on the dashboard with some findings. And if I go to the symgrep results, I can see that, oh, my source code that I've got here had a little problem in this particular class, and it has to do with some JWT validation on it. So, and you can even click on this link, and that'll take you into the file, and I can say validate. And there's the line that it was complaining about as I try to go in and validate a token inside of this API. So that's a nice example of wiring up some lightweight security scans into a build pipeline, parsing the results, and then getting those to display for the developers on the dashboard. So that's GitLab CI in its most basic form. Hopefully that gives you a good example of some of the different capabilities and the way that those things would work. And we'll continue to dig into some of the other services in the flight simulator as we push forward here during the session. So now that we've got GitLab CI covered at a basic level, let's take a peek at the way that GitLab's OpenID Connect identity provider sets up. And the reason that this is super important is because if you don't leverage this, what you're ultimately going to end up doing is storing a bunch of secrets, API keys, webhooks, things like that, to invoke external systems. You're going to end up storing it in version control or insecurely in places that maybe are not encrypted at rest or protected or audited when people try to access them. The other reason behind this is just to prevent long-lived tokens or access keys or service principal client IDs and secrets from being introduced into these pipelines when we could use more short-lived signed tokens that expire in an hour, for example. So this exists inside of a lot of the modern CI/CD systems now. GitHub and GitLab were arguably one of the first two CI/CD solutions that just said, look, like, we don't want you to generate long-lived AWS access keys or client IDs and secrets or vault tokens to access those particular services anymore. Instead, what we're going to do is build in an OpenID Connect identity provider. And the OIDC provider inside of these CI/CD systems can create a signed token for every unique pipeline execution. And then using that token, you can establish trust with an external service provider like HashiCorp Vault, for example. And then you can go read secrets from the vault rather than storing them in version control or in some other location. So the goal of this second piece here is for you to understand how to get a signed identity token from one of those GitLab CI pipelines. So GitLab very early on said, we're not going to implement secrets management. If you look at GitHub Actions, they did. There is a secrets option inside of GitHub Actions, but GitLab said, we're not a secrets management company. We don't have any interest in building a secrets manager. So why don't we just build an integration in to securely go out to a vault and grab a secret? And the way that they did that was using OAuth and OpenID Connect support inside of a running workflow to generate a signed identity token. And the way that you can actually request that from a given pipeline or inside of it is by using this ID tokens configuration. So what this is going to do in the ID tokens configuration, I specify one too many identity tokens that I'm going to need to authenticate to HashiCorp Vault, or maybe Azure Active Directory, or maybe an AWS or a Google Cloud project. So you could have many of them in there. I'm showing you one, which is just called vault_JWT, and there's an argument that you have to pass to it, which is the audience. What do I want the audience claim in the token to be populated with? And that typically is going to be who's the service provider that's going to be using this down the road. What's the URL? So in this case, I've got vault.sans.labs because it's my local running version of the Vault, but that could easily be sts.windows.net or sts.amazon.com. So we'll start to set up the different security token services for all these external providers. And what this does is when your pipeline runs, there will be an environment variable called Vault JWT that will have a signed identity token inside of it with that audience set up for us to use. Now, inside of the token, by default, you are going to have essentially a JSON web token, which is a base64 encoded chunk of data. There's three pieces to it. If you haven't seen one of these before, there is a header, then there's a dot, and then there's a payload, and then there's a dot, and then there's a signature. The header and the payload, the first and second parts, are base64 encoded, and you can easily decode those. So I'll show you how to do this in GitLab, but in order to understand how to set up trust with an external service provider like HashiCorp Vault, you need to know some of the key pieces of information in that payload in order to set the trust up. The first one is the issuer, who's issuing the token. And in this example, that's our GitLab.sans.lab GitLab server. Now, if you're on GitLab.com, it's going to be GitLab.com. If you're in your own environment, it's whatever you have set that up to run under, but that's who's creating the tokens. The next piece is the audience. And I specified this, if you remember inside of that configuration, I said vault.sans.labs, and we're going to set up trust to say, look, any tokens issued by GitLab.sans.labs with the audience of vault.sans.labs can access some Vault data. The other piece that's really important is maybe the claim of who is the pipeline that's currently running. And there's a couple of them that you can use. One might be like any pipeline inside of all of this DM DevOps repository. You also in the subject can get more granular here, which would be which branch is the CI pipeline running off of, or which tag is it running off of. And there's a lot of different things that you can start to narrow down scope for if you need to. So that's the composition of a token. Overall, as these pipelines run, that token is going to exist for any of these jobs that actually request it. So in this demo, what I've done is I created this little evil agent job down here, and I dumped that token environment variable out to the logs so we can actually see it and then decode it. And I can prove to you that it matches what I had on the slide a couple of minutes ago. So let's jump in and we'll take a quick look at this particular setup. So this is in a different repository. So if I go to the GitLab CI YAML file here, here's this evil agent that I set up. And you'll notice inside of here, I've got that ID token set up. So I'm asking GitLab, when this runs, I would like a Vault JWT environment variable to be populated with a signed identity token that has the audience set to vault.sans.labs. And then I've got two commands in here. One is the simple, let's see if this works, which is just run env, and we'll try to dump all the environment variables out. And then another one is a little more kind of way to hack around a safeguard, we'll say, some masking that's involved. And what it's going to do is base64 encode that environment variable. So if we go out to that particular repository, we'll look for the DM DevOps repo here and look at the pipelines for this one. You can see I've got a build here. It looks good. Looks like I was installing PowerShell and something the other day. And we'll scroll down and we'll find this evil agent output. And if we take a look here, what I wanted to show you, so let me search on this screen here for Vault JWT. And you can see it's pretty smart about masking secrets. So because it knows anything that's in that Vault JWT environment variable is a signed identity token, it doesn't natively just show it to you. So you can see that that's masked, which is a good thing. And that capability or feature exists in almost all the CI/CD tools. They'll stop you from making a mistake and accidentally pushing that out into the world. So that's the reason I had the second command in there, which was base64 encoding it. So you can see there, because I have transformed the value, it doesn't know that that's a secret. It just knows what the JWT is. So when I base64 encode it, it's not smart enough to say, well, I don't know what that means. Yeah. And as Sam just mentioned, that works in Jenkins as well. You can definitely transform a lot of this data and it still shows up. So we've got the base64 encoded value. Let me switch back to VS Code here and let me pull up a terminal. So there's a JSON web token tab here, and you can see I've run a couple of commands to basically export that token from GitLab into an environment variable called JWT. And then I'm going to base64 decode that, run that through a helper function that basically base64 decodes the payload. And now you can see exactly what's in that thing. And similar to the slide I showed you, we know who the issuer is, gitlab.sans.lab. The audience is vault.sans.labs. And we know that the project path is operations/DM DevOps, which is the actual repository that pipeline was running inside of. So all that metadata is there for us to use to set up trust over on the Vault side, which will be the last piece of our discussion. The other thing that's also important to realize is the issued at and the expiration of the token. How long does this thing actually live for? I just stole a signed JSON web token out of a pipeline. And if an attacker is able to do that, how long can they actually use that token for to access other services? So if we take a look at those dates, you'll notice this was on December 31st. So at 14:45 UTC time, it was issued. And then at 14, let's see. Oh, that must be the start there. Yeah, so they're not issued for very long, really, if we take a look at that. So that's a pretty short window there. And the reason that that's important is because, oh, that's not before. Let me do that again. It should be an hour. Just want to make sure that that's the right value. Yeah, so notice issued at 14:45 and then expires at 15:45. That's the right window I was expecting. So for 1 hour, this token is alive. And that may seem, kind of like a long time for those of you that are like, oh my gosh, the attacker can run around with this for an hour if they steal it right away. But compare that to the alternative, which is usually we're using long-lived credentials for this stuff. We're going to create an API key for Vault or an access key for AWS or a client secret in Azure. Those usually live forever because it's up to us as the humans to rotate them periodically. And we know that we don't do a great job at that. Usually those live for months and months and months or years at a time. And in this case, at least it's down to an hour. And once that expiration window hits, then they've got to compromise the next pipeline run and grab a new one. So it keeps these tokens as a moving target for accessing some of these external systems, which is a big improvement over the long-lived credential side of things. So the last step along the way is really just to look at the Vault side of things. So you've got a signed identity token, the issuer, the audience, that project path or the subject has constraints in it that we can use. What we need to do next is go to the actual service provider, which is in this case is Vault, and we need to configure the federated identity side of things. So over on the Vault side, the way that this is done is you go to the Vault and you turn on the JWT authentication methods. You just enable it. And then you configure it. And in that configuration, you're going to say, who's the issuer for the tokens that we trust? And that is pointing back to our token issuer, which is gitlab.sans.labs. And then we will create a Vault role inside of the JWT auth data. We're going to create a role called GitLab read write. And in here, we can further constrain based on the token's attributes. So what we'd say is this role, enable to impersonate it or sign in with this role, the audience has to be vault.sans.lab, and the project path might need to be operations DM DevOps. And then we assign a policy. This is the actual Vault permissions that you can do. What can I do inside of the Vault once I sign in? So maybe I can only read one secret from one path, something like that. Now GitLab can log in with that JWT, get a temporary Vault token that might only live for, again, 60 minutes. And I can use that Vault token to access some secrets as these pipelines are running. So the way that that's all set up is we grab our vault token, and we'll have vault write. It's a weird way to say login, but we're going to say vault write to auth JWT login, and we're going to pass it our JWT and the role that we actually want to assume. And if that works, we're going to get back a vault token that we can then use to just go grab some secrets from the ecosystem. So that's essentially how we can exchange the JSON web token for the vaults. Now, Sam asked over in the Q&A, is there a way to programmatically do all this? Yes, the Vault UI is really just a wrapper around the REST API. So everything is able to be done programmatically through the REST API or even through the command line interface. So as we take a look at our last piece to the puzzle here, I'll show you the Vault UI first. The access you're looking for in this JWT auth method, that's where you would go enable that stuff. But it even tells you if you want to manage this, you need to use the API and the CLI in order to do that. So if you take a look at the commands that I've got in this last shell, I kind of went through and just listed them. So like your vault auth list command will tell you, hey, it's enabled. And then if I read the JWT config, I can see that, okay, there's my bound issuer. I'm only trusting tokens from gitlab.sans.labs. Also, if I list the roles, I can see that there's the GitLab RW role, so the read-write role. And if I look at that role, you can see that I've got some things bound to it. So there's the audience binding. That's the audience that we trust. So that's 2 of the claims. And I don't have any bound claims on this one, which basically means any repo in my entire GitLab instance can assume this. That's potentially maybe overly permissive. But if I added something like one repo here, maybe this role name would be GitLab read write DM DevOps. So you can be very granular with the roles and permissions. So all that's in there. And then the biggest piece perhaps is the GitLab policy that you assign to it. So GitLab-RW is a vault policy. And if I read that vault policy, you can see, okay, here's the actual paths inside of the vault that I've got read, update, patch, delete, those sort of operations on. So yeah, Sam, the short answer is yes, that can all be programmatically done. So that completes the journey through our GitLab CI to setting up the JWT integrations with an identity token from GitLab, and then setting up trust over on the Vault side to use those short-lived tokens for accessing those things. So let's see, conclusion-wise, overall, what we've got here is if we look at the way that these version control systems, your GitHubs and your GitLabs, are integrating CI/CD, hopefully it was fairly obvious through that discussion that this is your easiest path to just be up and running with automation quickly. And as organizations are going through their DevOps transformations and their cloud native transformations, this is trending in the direction that everything is going towards. Most folks are starting to not use external or third party or even just other CI/CD systems because it's one more moving part and one more piece of responsibility that we have to manage. And as we look at how these things are integrating, it's very simple to be up and running quickly. As things have evolved, and I've been watching these tools for many years and seeing, okay, when are they going to get to the point of having parity with something like Jenkins? And with now some of the JUnit and the test results and the extensions inside of GitHub Actions being pretty mainstream and mature, I'm now at the point where I'm saying, hey, the reporting and the dashboarding is there. And I think we've got pretty good feature parity between all of these newer tools and then some of the legacy ones. The big benefit is the modern CI/CD tools support these OIDC identity tokens in short-lived access for these external cloud provider systems. The one limitation is I showed you how to do it with Vault Identity Federation with the JWT provider, is your cloud provider, your Vault provider, whoever, they have to support Identity Federation via OpenID Connect in order for all of this to work. So that is something to keep in consideration as you're evaluating the different types of tools that you might throw in here. I know I have conversations with folks quite a bit that say, oh yeah, my vendor's got OIDC Federation as an option, but I have to buy my way up to the enterprise plan of whatever, and it's going to cost way too much money, so we don't use it. Keep that in mind, because some of the other tools might just have it, and you might just be able to use it, and it's not an extra, ultimate or premium offering add-on in the ecosystem. So with that, I'll jump over to the cloud security flight plan. I know Lara, who kicked us off today, has got a more recent version of this, and Lara can post the link to this if you want to go check it out. But we've got a pretty extensive cloud security curriculum now inside of SANS, covering all the different topic areas that you might need in order to meet a lot of different roles and job titles inside of the cloud security world. So make sure to check that out and see which courses might fit your career goals the best. I'll leave it on this slide here as we head into the Q&A session. If you're interested in Sec 540 specifically, we've got the very first new version run is coming up. Ahmed is going to teach that. It's a live online. It's on Europe time, the last week of January, heading into February. David Hazar is going to be running it in San Diego in February, and then Jon Zeolla will be down in New Orleans and also in February, bringing a lot of this content into the live classroom as well. So check those out if it's something that you're looking to get into. I'll move over now to the kind of the Q&A sessions here, as we've got a few things that came up. And I did see one Zoom hand go up also. So if you've got a question, just drop it in the Q&A chat there, and I'll kind of go through those, and then we can open it up from there. So Sam asked, yeah, programmatically. So I got that one answered live. One of the questions came in from, how easy is it to monitor authentication using JWTs issued for pipelines? And if you're concerned about token theft, yeah, it feels like a detection use case that don't come from a runner. And I absolutely agree with that. The difficulty of this will depend on where all of your runners are. So if you're using the cloud hosted runner, so use GitLab's cloud hosted runners, for example, they're gonna have like thousands of runners out there. Your detection really is pulling down all the IP addresses essentially for all of their runners, which is kind of a dynamic list. So there's some challenges here, but you need to know what the baseline set of cloud runners are. And then you're looking for IPs using that token that potentially are not in that list, if that makes sense. So that can be challenging. Now, if you're in self-hosted runners, you're going to have a smaller IP set, and it actually might make your life easier. So that could be a reason to look at potentially running these on your own self-hosted runners versus the cloud ones. But yes, I'm with you. It's kind of just, where is that token being used at or from? And I think that mirrors kind of what we're looking for inside of the AWS and Azure ecosystem as well. That's what we'd be looking for, is, if you're expecting a token to be used from a consistent location inside of a VPC, and then it's used, by my laptop in New Orleans, for example, yeah, that could be a problem. So that's definitely what you're looking for there as far as detection goes. So we got that question answered. On the follow-up, okay, yeah, is there an example for AWS and Azure instead of the Vault? And what I'll do there is point you off into the GitLab documentation. So let me post the link to that we've got here. So let me see, GitLab CI. And this is the AWS one, but there's a little left nav menu where it gives you examples on getting into AWS, Azure, Google Cloud, Vaults in the list. So very similar setup to what I just showed you. So that's in the Zoom chat. If you want to take a look at that as well, that should get you started and moving in the right direction there. I know I saw a couple of questions come in about, getting access to the cloud flight simulator and some of the content that I showed. Obviously this is now powering the content inside of Sec 540, But what I will say is that Ben and I designed a lot of the simulator concepts as a baseline. And so keep your eye out this year, as we're always putting workshops together and releasing different bits and pieces of a lot of these concepts inside of just workshops that you can sign up for and register for free. And that's going to be used under the hood for a lot of the stuff that we put together this year. So I've already got something in the works with Simon on some things that he's wanting to do with Sec 488. And we're trying to put kind of a fun story together for a lot of those things. So if you're wanting to kind of kick the tires on this stuff, just bear with us. I'll put together a GitLab CI workshop at some point, and we can kind of get you access to some simulator style environments like I showed you, so you can go through and work on those things. So we'll get it to you. It might take us another couple of months to carve the time out to do it, but keep an eye on those workshops. Laura just posted the link there, and that'll get you some experience with it for sure. But that's about all I know for now, at least what's coming up on the roadmap. Before we wrap things up, did I miss any other questions that were out there? I saw anything else come in. With that, if I missed a question, feel free to reach out on LinkedIn and ask it. I appreciate you all jumping in and spending some time with us this early here in the new year. We'll go ahead and tie off the session for today. Thank you all for attending. Have a great rest of your week, and we'll catch you next time around. Cheers.